Hello, everybody. Good afternoon, and welcome to the Space for Twin Cities seminar dedicated today to cultural heritage. I'm Donatella Ponziani, and I have the pleasure to be the moderator for this session. I would like to introduce to you our distinguished speaker, Yolanda Patruno, who is a Earth Observation Exploitation Platforms Support Engineer in ESA. Marina Marcelli, who is the official responsible for the Monuments Risk Mapping and Geographical Information System in the Superintendence of Cultural Heritage in Rome, with Gabriele Leone, geologist and researcher in ISPRA, Italian Institute of Environmental Protection and Research. We have together with us also Dr. Hatos Agapiou, who is a senior researcher in the Department of Civil Engineering and Geomatics at the Cyprus University of Technology. Arianna Travaglia, who is the director at the Cultural Heritage Technology Center, which is part of the Italian Institute of Technology, and Piera Di Vito, who is a Space Solution Technical Officer in ESA. I would like to start the discussion with Yolanda Patruno. Yolanda has achieved a Master in Science degree in Aerophotography and Ancient Topography at the University of Rome La Sapienza. She holds a PhD, and she joined 2017 the Earth Observation Department, working as Earth Observation Engineering for satellite project focused on Earth observation data exploitation. Yolanda, welcome. First of all, given your expertise, we would like to explore with you the cultural asset protection, valorization, and fruition through the use of space technology and derived data. Could you please provide us with an overview?
Thank you, Donatella. Good afternoon, everyone. So, yes, sure. I don't see the presentation. Thank you. So, okay, I will start with the first slide. Talking about space applications for cultural heritage, I think we should focus on some concepts. The first of this concept is understanding. So we need to understand which kind of factors are affecting today cultural heritage. And this could be due to natural factors as subsidence, for instance, or artificial ones as urban sprawl, but even climate change is affecting cultural heritage. And still we have some research, let's say research scopes as the detection of new sites. Then we need to ensure that all the factors affecting cultural heritage can be secured somehow, and this could be done through the analysis of some of the other factors that can be monitored by with the Earth observation, and in particular the looting of sites, the air pollution monitoring, and the erosion of coastlines. These are only few of the factors that we can secure, and still we need to benefit from this technology by reaching and realizing risk assessment and use change maps, also providing non-destructive investigation for not only infrastructure realization, for instance, in urban areas, but also for the planning, the new excavations planning. A concept which is very important to me is the dissemination of cultural awareness, which is not always obvious. So continuing with the next slide, we can say that okay, thank you. We can say that the advantage of observing the Earth from above were already known in past centuries, in the past 2 centuries, as you can see here with these examples. So not only for documentation purposes, but also thanks to accidental discoveries. What EOData can provide today is not only a systematic and diachronic observations for instance, analysis over time, but also in high temporal and spatial resolution that can be used for change detection and classification techniques, among the others. What we have seen in recent years is also some applications of artificial intelligence and machine and deep learning techniques in this topic, But the focus should be always the importance of the multi-source data integration. This is essential to produce value-adding products, so space-based products, in situ observations, but also the aid of ancillary techniques, other techniques as the ones that I listed here, but there are many others have to be taken into account. In the following slide, we can see that we can start with some of the examples that we can have today. This is the UNESCO World Heritage List and World Heritage List in danger. We have many sites here, so 896 are the World Heritage sites and 53 are the sites in danger. In recent years, many of the sites have been analyzed through the usage of Earth observation applications, and still today, currently, many of them are under this kind of analysis. Starting with the example of the next slide, we are here in Sudan, in Africa. So this is an example where we could be able to derive cartography from satellite data. We can merge and integrate several layers into GIS with topography, with optical and SAR data, 3D rendering of structures. And also in the image on the right, you can see there is the possibility to analyze, for instance, the SAR backscattering anomalies that we can have over a detected anomaly in the environment. And second example, the next slide, is coming from UNITAR. So we are here in what we call crisis areas, where we have not accessible environments, and the concepts of preparedness, response, and recovery, which are typical from disaster risk management, can be applied also to cultural heritage management. The two topics are not so different. A third example in the next slide is concerns the urban area, urban example. So we are here in historic central Rome, which is inscribed in the UNESCO World Heritage List. Here, thanks to the interferometric techniques, it has been possible to analyze the ground motion detection of structures. In the following slide, we are now going to focus a bit on the Earth observation missions that we can use. Here, I would like to point attention to Copernicus data, and so the Sentinels family, which contribution, in the next slide, please, which contribution as, together with the contributing mission in the recent years, has facilitated a lot the management of cultural heritage, not only during emergencies, but also as a daily routine, so for the monitoring, mapping, and preservation. The same concept I was mentioning at the beginning, where I come back now, is the concept of awareness. So there is a need to transmit, to share the awareness about Copernicus data, available Copernicus data today, what they can offer, and that, which is their potential. In the next slide, we can see an example of Copernicus data. And before talking about this example, I just wanted to say that it is a fact that preventive action have to be preferred to reactive actions. So in order to achieve this, we need, and we have today, a very high spatial but also temporal resolution. Even other actions have to be undertaken in this topic, in this domain. There is the need to strengthen the communication and the synergies between EO experts and cultural heritage managers. And there is the need to provide user-ready products, which is something that is really delicate today. And also the two entities, so the two words, I mean, the cultural heritage management and also the Earth observation experts need to collaborate together to generate practices that today are a bit missing, or the integration of technology into the cultural heritage world. I would like to leave you with this imagery here. This is a processing of SAR imagery, Sentinel-1, one of the first acquisition of Sentinel-1 over the Fiumicino airport in Italy, close to Rome. The scope was not to identify archaeological structures, but it's clear how you can recognize the harbor of Trajan with this hexagonal shape in the middle of the image. So this is a nice image to me. Thank you very much.
Thank you very much, Yolanda, for this very interesting introduction. You set the scene, the importance of collaboration and cooperation among Earth observation expert, space expert, and the cultural heritage expert. We thank you very much. We now hand over to two speakers, Marina Marcelli and Gabriele Leone. Marina Marcelli is an archaeologist and a geographer. She works in the Department of Monument in Rome, where she is responsible for some archaeological areas in the south of Rome and for the Aurelian walls. She is together here with Gabriele Leone, who is a geologist specialized in geographic information system for land planning and protection. And he is a researcher currently in ISPRA, Geological Survey of Italy, and his area of expertise goes in geohazard analysis, geohazard modeling, and risk assessment. I would like to ask both of you, can you show us how do you ensure the conservation and management of Rome's urban archaeological heritage? Thank you very much.
Thank you, and good afternoon to everyone. First of all, I wish to present my department, the Sovrintendenza Capitolina. Next slide, please. Our mission is mainly related to conservation, management, and enhancement of the historical, artistic, and archaeological properties of the municipality of Rome. The cultural heritage owned by the capital is maybe the most consistent and variegated in the world. Museums, archaeological sites, monuments, fountains, gardens, and so on, as you can see by these few examples. Next slide. The whole historic center of Rome, we have heard in the previous presentation, was added to the World Heritage List in 1980. The site includes monuments of incomparable artistic value, produced over almost 3 millennia of history and bounded by the urban walls, which we can consider the very symbol of the UNESCO site. The Aurelian Wall, built at the end of the 3rd century, when Rome was a town with a population of more than 1 million people, still ran for over 13 kilometers. Additions to protect the Vatican and Trastevere districts were made by the popes between the Middle and Modern Age. The wall served as military defense until September 1870, when the Italian military corps breached it near the Porta Pia and captured Rome. It also defined the boundary of the built-up city. Next slide. Recently, after the collapse of a sector, the Aurelian Wall has been called the giant with feet of clay because of its fragility. The forces of our office are mainly focused on counteracting the damages caused by anthropic and natural agents of deterioration. The Observers Project GIS was born in 2010 as a support tool for operational decisions. It consists of data banks and procedures functional to programming maintenance and preservation of the big monuments under observation that are walls and aqueducts. The work was done by an interdisciplinary team made up of archaeologists, architects, restorers, engineers. All information about historical data, state of conservation, restoration, main degradation agents are being linked to the geographical polygons of the single elements, gates, towers, walls, to define standard levels of risk. The result is an overall analysis of hazard and vulnerability and the implementation of a risk map of the whole circuit. Now we can have an effective tool to develop restoration projects rapidly. So Gabriele will go on with the Protego project.
Thank you very much, Marina, for introducing us in Rome. Happy to meet you here. Rome walls especially was one of the case studies of the Protego project. This was funded under the European Joint Programme Initiative on Cultural Heritage and aim at applying a new space technology, satellite radar interferometry, INSAR, for the protection of cultural heritage against geohazard. The methodology developed starts with the identification of main geohazards affecting UNESCO World Heritage List sites all around Europe. Most updated and scientific reliable scenarios on three main geohazards, landslide, earthquake, and volcano, have been analyzed and integrated at continental scale with available satellite radar interferometry data to obtain an homogeneous ranking of each cultural heritage property with respect to natural disaster. This is the risk index you can see up in the slide. Then 7 of these sites, these 400 sites, were chosen to test a more detailed approach. It runs in few steps from the preliminary, as you see in the bottom, from the preliminary INSAR analysis to detect millimetric ground displacements over time, through the field survey for a proper calibration of the remote sensing data, to a final damage assessment for a correct planning of mitigation and restoring intervention. So let's see in the next slide the Rome Walls case study. It took advantage of the great job done by the local manager, the Progetto Osservatori mentioned by Marina, that represents a GIS-ready damage inventory that is being compared with well-known geohazard affecting the city center, mainly landslides, as you see in the upper section, that happen occur along the 7 hill slopes, and ground settlement along the Tiber River Valley. In the next slide, please, for about 30 selected parts of the walls seen before, undergone a field survey to identify actual relation between the ground displacement highlighted by INSAR monitoring and the damage reported. Here you can see the southern edge of the wall, partially cut about a century ago to raise the railway embankment close to the only railway bridge of Rome. Persistent scatterer obtained by satellite radar interferometry for Cosmos SkyMed data for the period 2011-2014, the left map, highlight an overall settlement of the area that is mainly due to the ground vibrations because of the passing trains and recorded by PS. See an example bottom right of the settlement. But the main issue concerning the wall stability is related to the differential movement you can see in the southern left side between the northern and the southern area. During the time span analyzed, the northern side settled down by 1.7 millimeter per year, but the southern side settled down at about 3 times this rate. This stress applied to the ancient building foundation caused a partial wall cover detachment that was restored in 2012. So next slide show the results of all these monitoring guided by satellite data and then verified in the field to understand the actual interaction between the ground movements and the building damage recorded in order to set up a satellite monitoring system capable to prevent future damages. So INSAR analysis provide a large number of site-wide displacement measurement points with small cost and without impact on monuments. Ongoing and future high-resolution monitoring, as the one ongoing by Copernicus European Ground Motion Service, allows stakeholders to properly plan intervention as restoring and mitigation intervention. And as already said, the good results obtained foster the improvement of multidisciplinary approach to solve complex cultural heritage stability problems. Then with the next slide, I encourage you to follow us on the web, and we want to thank you for your attention.
Thank you very much, Marina. Thank you very much, Gabriele, for this overview and for highlighting the very rich cultural heritage we have in Rome. But not only that, the importance, again, of basing the analysis on several data and on having a multidisciplinary approach whenever we want to preserve the richness of humanity. I would like now to introduce our next speaker, who is Dr. Athos Agapiou. Athos is a senior researcher at the Department of Civil Engineering and Geomatics at the Cyprus University of Technology. He holds a PhD in remote sensing archaeology, and his research interest includes the analysis of Earth observation satellite data blended with archive, aerial, and other information, as well as ground prospection investigation over archaeo and landscape. I would like to ask to you, Athos, the following question. Which is, in your opinion, the connecting layer between the space domain and the cultural heritage protection and fusion? Thank you.
Good afternoon to all. Let me first start by thanking you for inviting me to this exciting webinar, and many thanks for this interesting question, as this leads to my presentation entitled as Cultural Heritage, the Missing Layer of the Space Program. Despite what most of the people think, remote sensing for archaeological applications and cultural heritage management in general is not a new topic. There was a great interest all around Europe and beyond dealing with this topic, especially in the last 2 decades. Earth observation and how we can better extract useful information from satellite sensors are a focus point of research for several institutions nowadays. On the next slide, on your left part of your screen, you can see a density map over Europe. This was based using scientific literature, meaning publications in scientific journals related to remote sensing and cultural heritage and Earth observation. The map, as you see, indicates clusters according to the citation metrics for remote sensing archaeology used as a keyword in the Scopus bibliographical engine. Red color indicates areas with high density of institutions received a high number of citations. As it was found from that study and another more recently one, scientists explore various ways and types of sensors for their studies. As you can see in the right part of the screen, high resolution Copernicus contributing missions like the Worldview sensor has attracted the interest of the scholars. However, we can see other satellites too, with medium resolution like the Landsat, which has already been used in the past. We have to say that also Copernicus Sentinel sensors also seem to have attracted the interest of the scientific community, mainly driven by the full, free and open policy known as the FFO policy of the Copernicus program. The visualization of this relevant scientific literature, as we call it, is shown in the next slide, please. So what you see here are the core studies of the scientific reports, and you can see that the majority of them are dealing with remote sensing and cultural heritage and archaeology, of course. However, we can see several other applications targeted, designed to address specific questions and problems. This has been already reported in the past by the scientific community. The Copernicus program has already started to be used for cultural heritage applications and especially for heritage management. As you can see in the next slide, land displacement maps measured with millimeters of accuracy can be estimated after an earthquake event as the example of an earthquake we use as a case study here in the western part of Cyprus occurred in 2015. The high temporal revisit time of the Sentinel-1 image provides us with the opportunity to process images before and after an earthquake event, and then we can blend this information together with other geographical data and ground stations, of course, using geographical information systems to perform deformation analysis. Such damage proxy maps are critical for heritage management, especially after natural or man-made catastrophic events. Similarly, we can also explore the optical Sentinel-2 image, as you see in the next slide. So here we use classification analysis of multispectral optical Sentinel-2 data, which can be used to map urban areas for extended areas and regions. We also use archive information from other source of inputs like the Korean Land Use Land Cover Program, and when we blend this information together, we can estimate the trend and the overall change in the vicinity of the archaeological site and the surrounding areas. So other legacy data like the Landsat program can be explored to analyze the thermal conditions of historic buildings blended with Earth observation big data cloud platforms. On a running project that we have, we try to estimate thermal anomalies at the municipality level and then try to downscale this information at the semi-micro and finally into micro scale level. Of course, all these examples I showed before are only a small part of the existing knowledge that researchers have and know how they can use Earth observation and of course the Copernicus program. The question that remains is how we can further explore the Copernicus program for the benefits of cultural heritage and cultural heritage management. As you see in the next slide, new developments in the domain of image processing, like the use of big data cloud platforms, for example, the DIAS, the Google Earth Engine, the NASA Hive platform, and others. Also, downscaling techniques that can increase the spatial resolution of satellite image will definitely impact and definitely improve our capacity to better monitor cultural sites from space. At the same time, we have seen the technological improvements of the space sensors. Now we have sensors with even higher spatial resolution have become available to researchers. And of course, now we have also the opportunity to work with data, even with video frames from satellites. If we want to see and understand the whole picture of how Earth observation and especially the Copernicus program can really support cultural heritage, we have to go back and see what cultural heritage requires and what cultural heritage stakeholders need. As you see in the next slide, disaster risk management cycle is composed by 6 steps, starting from the context, then going to the identification of the risks, then we go to analysis and evaluation of that risk, and then finally we go to the treatment and the monitoring phases. These steps are also known as preparedness and response phases. Also, the last stages are also known as recovery and mitigation actions. As we have recently demonstrated, Earth observation and Copernicus program have definitely much to offer for cultural heritage monitoring and protection. As we see in the next slide, Copernicus program that includes both Sentinel sensors, Sentinel-1 and Sentinel-2 definitely, as well as the Copernicus contributing missions, can provide diachronic observation and ready georeference products. All these data and products can further use to support the disaster risk management cycle for cultural heritage. The free and open access policy and the remote observations, especially in areas that are difficult, as you have seen before, difficult to access on the ground, are also important parameters that we have to take into consideration when we deal with Earth observation. In my point of view, the tricky part that remains is how to increase the awareness of the potentials of how Copernicus program and how we can further promote the potentials at benefits to the local societies and communities. Still, cultural heritage is a missing part of acting as an individual thematic Copernicus service, which could eventually, in my perspective, promote Europe itself as a sentinel of heritage all around the world. Thank you very much.
Thank you very much, Hatos, for this overview. Very interesting presentation, excellent presentation. You highlighted on one side the importance of our program in support of Copernicus program, and the importance of the new sensors, the new system, the high resolution we are going through, as well as in your activities, as well as also the importance of sensibilizing society to and the scientific community in order to better use and to exploit to the maximum the potential of our Earth observation satellite. Thank you very much again. I would like now to introduce our next speaker, who is Arianna Travaglia. Arianna is a coordinator at the Cultural Heritage Technology Center, which is based in Venice. She's adjunct professor at the University Ca' Foscari. She is an internationally recognized specialist in landscape archaeology, a field to which she is contributing through the application and expansion of innovative digital surveys technologies in support of more traditional archaeological field methods and of research. Arianna, welcome. Would you please explain us in which way landscape planning can be informed by archaeological impact assessment incorporating remote sensing data?
Thank you for the question, and thanks also for having me here today. Now, from the example that we have seen so far, it is clear that the potential and the practice of Earth observation for both monitoring and detecting cultural heritage sites has clearly reached a certain level of maturity. And we also know from the other point of view, can you hear me well? I think
now better.
Yes.
Now
okay. Better. Sorry. Does it work?
Yes, now it's working.
Okay, so I was saying, we know also that the so-called space verticals have a crucial role to play in a smart ecosystem as a technological enabler, and they can be at the core of cost-efficient management models for urban and suburban landscape. But the way in which these can be extended to cultural heritage is not always so clear. So I hope today in my brief presentation to be able to explain it and to show also how EO data can be used for cultural heritage monitoring and managing to be useful for local governments to deliver better, smart solution, and how they can also result in revenues through the saving of using such data, that using such data can ensure. The next slide. And the one after, please. Thank you. The detection of buried site is not just a pinpointing activities, meaning that it's not just putting a dot in a map, but the archaeologists normally store into geographic information system, as we have heard before, the nature and the attributes of the features they have identified via EO data. And GIS are used to handle the complexity of data that is necessary to interpret correctly these features that have been detected. It is only the whole amount of information that makes possible to decode the trace, and that goes well beyond recognizing just a shape on Earth observation data. The possibilities, and next slide, please. The possibility offered by GIS of mapping and tagging several hypothetical archaeological objects in one single system enable the creation of overview maps that can be further elaborated and become real charts of archaeological risk assessment based completely on remote sensing identification. Clearly, these maps can become really powerful instruments for cultural heritage protection. And the benefits, next slide, the benefits of using EO data to get these type of results are quite clear. They provide the capacity of checking large blocks of landscape in a limited time. They enable also to get a global vision of landscapes. But in the last years, next to these advantages, we've been also able to get new ones through platforms like the one mentioned before, Copernicus, because we now have the availability of systematic EOD data time series. And these are, in a sense, sort of game changers, because they enable to check tentative sites over different seasons and over different environmental conditions. And they enable to detect changes in the status of the sites and also to reduce the fieldworks activity of the archaeology. Most of all, the availability of this time series can provide crucial information for landscape planning. And this is, as we will see in the next slide, a real crucial point. This because EO data, in particular the time series, can be used to provide background information for regional and national landscape planning. Let's think about, for example, the creation of small-scale or large-scale infrastructure and how they can be impacted by fortuitous discovery of buried archaeological sites. The systematic use of EO data for detection of cultural heritage sites can prevent these adverse impacts that there can exist during urbanistic development phases, as the archaeological risk can be taken into account already before in a planning phase, and planning can be done based on the available archaeological information. So the use of EO data enables a more accurate landscape design and a better integration of landscape aspects in the spatial planning and in the development process of a territory. Next. And in front of this potential, however, it's not always possible to integrate information detected via remote sensing data within existing planning instruments, like, for example, the town plan or local strategic plan. And this is simply because, except few best practices, few cases, there is a lack of dedicated space within them for a very volatile type of information as a detected trace. Specifically, within the information system that most of the local governments use for landscape planning, there is no specific layer, GIS layer intended, dedicated to archaeological risks. And only these instruments normally only works for out-of-the-ground cultural heritage. So now we can only hope that in a near future, local governments will be able to accommodate also information from remote sensing, as they can often be the only source that can effectively support in preventing risk and mitigating consequences, both physical consequences like the damaging, the destruction of the cultural heritage site, or economic ones, because, for example, the cost of modifying a development plan that has already started is much higher than modifying it when it's still in a design phase. Next. And to make the most of the use of EO data, it is crucial that local and national government agencies are put in the condition to create, or where they have them already, to improve their digital infrastructure for integrating in a very organic way EO data derived information, and treat them as any other indicator that is normally kept into consideration when planning or managing territories. Next. So finally, looking at the future, and we have heard this mentioned before in some of the previous presentations, there are many rapid changes that we are looking at in the domain of remote sensing and cultural heritage. First of all, what used to be done visually on photographs or on screen by photo interpreters is now progressively being done automatically by machines, thanks to the advancement enabled by artificial intelligence. In the next years, while the technology will progress, the detection and monitoring will become much easier, as they will be done automatically. And I take here the opportunity to mention, for example, a recently launched research project of my center in collaboration with ESA Lab to automate the detection of cultural heritage features on images imageries from Copernicus platform through artificial intelligence. The acceleration that we will obtain in the future with artificial intelligence will enable future local governments to have plenty of information that they can use to better manage their landscape. Next. And to sum up my position, I'm looking forward the integration of EO data-derived information for cultural heritage in all the instruments available to local governments, land use planning, landscape planning, impact assessment. And most of all, more broadly, I'm looking forward the integration of EO data in landscape decision-making, because EO data applied to cultural heritage detection should provide really the baseline material for professional in spatial development, like planners, architects, engineers, and others, so that they can really help us to maximize the protection of cultural heritage. And I hope I answer in full to your question.
Thank you very much, Arianna, for this very, very interesting presentation, so pointing out the importance of having a holistic approach, or not only in observing, but in preserving the cultural heritage while having a very good landscape use planning, sensibilization of local governments. So very important message. Thank you to share it with us. I would like now to introduce our last but not least speaker, who is Piera Di Vito. Piera Di Vito works at ESA in the Space Solution Department in the Telecommunication and Integrated Application Directorate. She supports industry to develop application in several domains, which present a strong potential to become commercial in short and medium term. And she has an extended expertise. She holds a master's degree in telecommunication, and she is going to introduce to us to the secret of her work. Could you, Piera, could you please show us some concrete examples of successful application of space technology in cultural heritage prediction and fruition? Thank you.
Thank you. Yeah, the first, next slide, please. So this is just a quick introduction about what we do at Space Applications. As Donatella said, we support industries providing funding and expertise to support downstream services based on at least one space asset, so like Earth observation, satellite navigation, or satellite communication, integrated with terrestrial assets like VR, AR, artificial intelligence, to develop downstream services in several domains, which span from maritime to aviation to healthcare and smart cities. Next slide, please. So I wanted to present this slide regarding the partners, because the projects I will present are not research and development related. So we're talking about real services that the partners and the users will really use. So in my department, we don't develop R&D. We look at commercially sustainable service. And what is interesting is that if you look at some of the partners who have established agreement with, you will find some of the cities like Rome, Torino, L'Aquila, the Abruzzo region, but also Groningen, like for example in the Netherlands. And all the projects you will see are tailored on real needs. So they will address daily issues that the municipalities address in their daily work. The next one, please. So this is one successful project that we have completed, that the industry has completed thanks to the support. And what I think is important from this project that it shows is the multidisciplinary approach, because here you will not see only the Earth observation data that we have also seen during the previous presentation is plays a key role when we talk about cultural heritage. But here there are also UAV, so remote air vehicles. There is the satellite communication asset. Here they are using so different data, terrestrial and space, in order to provide safeguard, valorization, and management of site visitors. What is interesting is that, for example, here Earth observation is used for the identification and evaluation of environmental hazard, identification of changes, and the satellite navigation asset is used for the ground surface deformation mapping or for area remote sensing data acquisition, and satellite communication for data transmission from sensor network. So if until now we have seen that Earth observation plays really a key role, I think that this project can really show that a multi-data approach can really make difference. And the next slide, please. So this is a project I'm particularly proud about. We have started about 2 years ago to cooperate with Roma, L'Aquila, and the Abruzzo region and Torino. And what I would like to stress is that not so obvious that municipalities that are currently facing so many real challenges pays attention and time to technologies. So we have seen the Sovrintendenza Capitolina that is part of this team that helped us to understand some key themes on which our opportunities have been tailored. So what we have done together with the municipalities and the region has been to identify 4 key thematics, amongst which cultural heritage fruition and preservation was one of them. And we have issued an announcement of opportunity where ESA was has co-funded initiatives to the bidders interested to address and try to solve the issues and challenges that the municipalities pose to them. The next slide, please. So we have started with the cultural heritage, and last year we have issued it. And despite the pandemic that didn't make the work easy to anyone, we're proud to say that we have just kicked off 10 activities between cultural heritage and law enforcement. And in particular, 6 of these activities are focusing on cultural heritage, safeguard, and fruition. These activities triggered the interest not only from the municipalities we had already the agreement in place, but also with the Italian Minister of Cultural Heritage and Tourism. And of course, we could support them also thanks to the support of the Italian Space Agency. They have just been kicked off, so they really just started after an incredible work that the consortia have done. And they are trying to address, as I said, the needs from the, as example, the city of Torino. And we have one of the first project is Phase 3. And the idea here is that they want to design and to develop a service based on integration of IoT sensors and Earth observation to provide monitoring of the public green, and in particular in historical areas. Or if we look at the Pomerium demo project, where they want to develop and to demonstrate a cultural heritage monitoring and management system. And again, here they want to tackle several challenges that goes from the pollution in urban areas for the cultural heritage, to the movement of the soil, to anthropic issues like the waste in the also cultural heritage areas, or the Vaduz demo project that will use virtual reality and augmented reality to combine with based on 5G network and satellite to enrichment of the tourist visit experience. And in the next slide, I complete with the last 3, but not less important, like the Amor Demo project that will provide safeguard and fruition of cultural heritage. And here again, the multidimensional approach, including UAV and Earth observation data and sensor will make the difference. And we have also one study that will focus on sustainable tourism using virtual guides and augmented reality, giving real-time information on tourist flows, or the Extension Demo project that will focus on the city of L'Aquila, and they will demonstrate an end-to-end cultural heritage fruition service where the user may acquire detailed information on surrounding places thanks to augmented reality and through the accurate localization. So again, what I want to stress is that these projects are real, and they will become real services that hopefully in the short, medium term, you will be able to use. So we're not talking about far things in space. We're talking about downstream user services that you will hopefully see in 1 or 2 years used in your municipalities, in your cities. Because here we started with Italy, but of course the idea and the hope is that they will become applicable and used all over Europe and even more. So I thank you for your time.
Thank you very much, Piera. Thank you for this overview of this rich project to highlight the importance of having on one side the scientific research and an holistic approach, but also on the other side to have service that can be used, easily used. I would like, we have a few minutes for us for a session of question and answer, and I would like to ask to the participant, in your view, what are the key takeaways of this seminar regarding the protection, fruition, and management of cultural heritage sites? I would like to start with our guest from municipality. Perhaps Marina, would you like to start?
Thank you. Just a couple of considerations from the point of view of an archaeologist. From more than 10 sessions, it emerged how fragile our cultural heritage is, strongly exposed to natural and anthropogenic risks, but also that the knowledge of the monument itself and of the context in which it is located is the basis of all the activities necessary for the prevention, conservation, and fruition. Today, it's evident more than ever that research in this field must necessarily have an interdisciplinary approach. We have in all the intervention this. The presence of technical scientific discipline is essential to activate risk monitoring and assessment techniques, which allows us to identify the most suitable methodology for conservative intervention. Another point, to my view, interesting, at the same time, there is a growing attention from the public toward our cultural heritage, which causes an increase in visitors into the areas that often compromises their conservation, as shown by the cases of Pompeii and Venice too. And it's therefore essential to find a suitable communicative language about scientific knowledges to make ordinary people participate in decision-making processes regarding cultural heritage. This kind of seminar of today turns out to be the correct approach to both issues. Maybe Gabriele want to say something else? Gabriele?
Thank you, Marina. Yes, so you said almost everything. Let me highlight that as we have seen, there is a huge amount of data and services coming from satellite Earth observation. Our project and yours as well shows that we need to learn better how to use these services and data by testing new technology and calibrating the observation by field survey does to couple somehow remote and field monitoring. I think this is the key to better use these applications. That's all.
Thank you, Gabriele. Athos, do you have anything to add on that? You have been mentioning the importance of several of the points that have been already tackled. What is your key takeaway?
Mm-hmm. Yeah, thanks. Very interesting presentation. Let me first start with this point. It's really interesting presentations to see all these applications dealing with Earth observation, how this can really touch cultural heritage application and management in general. What I want just to highlight is that, adding on the previous speakers, is that nowadays we live in an era where we have a lot of data coming from Earth observation. We have both optical and radar data in high resolution. Some years ago we couldn't dream of that. So nowadays we have all this data, and now we have the capacity to process a large volume of data with artificial intelligence and machine learning. So we have novel ways to go through all this data and to do multi-temporal analysis and to further investigate and all this capacity that Earth observation and in general remote sensing can offer for cultural heritage management. So I still think that the most critical, and I really enjoyed the last presentation, a critical point that needs a lot of work is that how we can bring these services back to the society and bring these services to the people and to the tourism, but just the people, and to the education and to the heritage managers that are responsible for safeguarding and protecting cultural heritage all around the world. I think this is very important thing, and this is why I wanted to highlight that Copernicus can really play a critical role in this point of view, and this is another value that is coming back to the Copernicus. So if we can further explore as Europe, if we can further explore the Copernicus, the European Copernicus program for cultural heritage, this will be an added value not only for cultural heritage itself, but this will be an added value for Copernicus program. So this is really important, and I think this is where research is going in the next years. So yeah, this will be my short point. Yeah.
Thank you, Athos. Arianna, would you like to give us your key takeaway with respect to what was presented, but also said by our speakers?
Yes, well, I can only agree with the comments I heard before me, but I would like just to bring in another thought for you. You know, archaeology started over a century ago with remote sensing, with balloons and airplane, and then most of the time their work was the aim of their work was to discover new archaeological sites. Now we have been going in so many other directions. Now we have heard today that remote sensing is not only discovery, but is becoming monitoring, is becoming managing. We heard the presentations before, they were telling us exactly this. And now even more in the last presentation, cultural heritage is also a way to start new services, so new work, new jobs, new enterprises, new companies. So it's also creating a different industry. And I think that archaeologists 100 years ago, when they started to use remote sensing, could never have imagined this. So I hope that the possibilities will continue to grow, and there will be probably many possibilities in the next years that we cannot even imagine now, as well, the archaeologists 100 years ago were not imagining even the point in which we are today.
Thank you very much, Arianna. I fully agree. And now we are about to finish, but I would like to leave the last conclusion words to my colleagues, to Piera and to Yolanda. Yolanda, what is your key takeaway and with respect to the presentation we had today?
Well, I'm really happy because today we went through so many important topics and open points, and yes, it was a very nice time spent in this way. I agree with all the comments actually that have been done so far. It's true that we have these two major, let's say, areas, so the commercial aspects and also the research aspects. I think that both of them need to go forward, of course. The research is very important because can give maybe the basis for a future commercial products. And I really think that it is important to encourage the use of Copernicus data and this transmission of awareness that I was talking about. So it's really, yeah, that's my point. And I think that everyone really set the scopes of this discussion. Thank you.
Thank you very much, Yolanda. Piera?
Yeah, I would like to thank you, everyone. And I would like just to highlight something that may seem obvious, but for me was not so obvious. So the fact that this is an event organized by the European Space Agency, and we are seeing scientists, engineers, talking with archaeologists. So two parallel and apparently far words are trying to work together and try to translate the different languages for a common purpose, which can be for monitoring or exploiting or safeguarding. But I think what is impressive is that really we are trying to do something together, despite we have completely different backgrounds. And at least for the projects where I've presented, this was really something that made a difference. The fact that the humanist part was happy to provide the real needs, and this was translated then in technologies solution.
Thank you. Thank you for your last word. That really conclude on a very positive note, the importance, pointing out the importance of working together, not isolating the different competence, but enriching one from the background of the other. I think that we are now running out of time. I would again like to thank you all for your presentation. It was a very instructive hour spent together with you. I would also like to thank all those who are following us and those who have helped to organize this session. And I would like also to invite you to join us for our next webinar next week on the 15th of December. We are going to speak and to talk about smart mobility. Thank you again, and have a nice evening.